Hello and welcome back to Car2 Geospatial Solutions. So this tutorial will have a series of its own as we are going to learn about a new software namely Erdas Imagine. So as you all might recall, this software, the Erdas Imagine, is basically a remote sensing software. So it is mainly used to perform satellite imagery analysis uh, in the likes of performing geometric and radiometric corrections to the images, classification of images using the supervised and unsupervised methods, performing change detection analysis, and also perform the accuracy assessment. So as a first one in this series, we're going to download the satellite data from the internet. Then we're going to create a band composite. That is, we're going to stack uh, all the layers into one single composite image. Then we're going to subset the image based on a given steady area's boundary. So we're going to download the data from the net and then stack the image and then create a subset of the image based on the steady area's boundary. So let's download the data first. So in this tutorial, I'm going to download the data from the Bhuvan web portal. So this Bhuvan portal is maintained by the Indian government, and as you all might know, there are various web portals for downloading the satellite data. Say for instance, the USGS Earth Explorer for downloading the Landsat data, and also the Copernicus Earth Hub portal when it comes to downloading the Sentinel data. So it is based on your discretion, but in this case, I'm going to go with the Bhuvan portal. So the data that we're going to download is from the ResourceSat satellite, which uses a sensor named the LIS-3 sensor, right? So let's open Google first. So just go to this web page first. Type in Bhuvan. So click on this first link here, and then there's Bhuvan 2D button here. So first of all, you have to log in. In case if you are not a registered user, you first have to register your credentials here. So for that, just go to this login button here. So since I've already registered, I'm getting the name and password here. In case if you are a new user, you have to click on this button. So it will be asking you all these details. Just have to fill these details and click the submit button, upon which you'll be getting an activation link to your registered email ID. And if you automatically link, you'll be automatically logged in, right? So it is very simple. Let me go back again. Okay, done. So I have logged in. So the next step is you have to click on this Bhuvan Store link here. So in this page, you can see all the satellite data products that are currently available. So as I said already, we're going to download the data from the ResourceSat satellite from the LIS-3 sensor. Okay, that is the radiant imaging self-standing sensor. So this sensor has a spatial resolution of 24 meters, right? So just have to click on this link here again. So as you can see here, these are the places which are covered by this particular satellite. First of all, you have to choose the study area. So let me choose my study area as Chennai. So you have to just type in the study area here and then press enter. So click on the first link. So the study area has been pinpointed here in the viewer. So I don't think this one single tile will cover my entire study area. So what I'm going to do here is I'm going to download these four tiles, right? So that it will be covering my study area wholly, right? So what we have to do for that is that you have to just go to this tab here, right? And then press this start button. Okay, now just press the shift button and then select the tiles which you want. So let me select this one, this one and this one, right? So I've selected 4 tiles in total. So after selecting it, you just have to press the stop button again and then press the next button here. So these are the data that are available for these 4 tiles. I'm going to download the latest data, that is the data that is being captured in the last few years, right? So let me just look for the latest data. As you can see here, some data are in 2019. Okay, so I'm going to go with this February 22nd, 2019 data, right? So you can also view the data in the viewer here. Just have to press the view button here. So it is showing this in the black border here. Okay, so I just have to press the download button. It is getting downloaded, and then you have to do the same process for the remaining three tiles. I just have to make sure that all the remaining three tiles are the same date, on the same date, right? So the date which I have marked here is 22nd February 2019. So I just have to make sure that the remaining three tiles are also captured on the same date. Okay, so let me just go down further. I can see another image here being captured on the same date. Let me just press the view button here. So as you can see, this is the tile. So just press the download button again, and then close this one. You can also close this one. Let me go again. I have to see for 22nd February. This is 22nd Feb. You can also view it here. It is the data for this tile, and then you have to download the last tile. So for last tile, I think it's this one. Yeah, it's correct. Click on download. So you have downloaded the data for all the four tiles. So all the four tiles were captured on the same date, right? So now you have to extract these zip files. So just go to the just go to the downloads folder. I'm going to extract them and put it in a single folder now. So these are the four zip files which I have downloaded now. So let me just extract them to a new folder. Extract files. Let me give the folder name as list. Okay, so it has been extracted to that list folder. Okay, so now we can open the Erdas Imagine Software again. Download the data. We just have to create the band composites. So since you have downloaded the data for four tiles, eventually you'll be creating a band composite for four images, right? So for that, just open this raster tab here, and then go into this spectral drop down. And as you can see, this the first one is a layer stack option. Uh, Select it. So in the input file, you have to feed in the bands of each image, right? Click on this folder option here. Navigate to the folder in which you have downloaded the data. So as you can see here, these are the data folders. Each folder will be having the bands of that image, right? So as you can see, these are the bands within a particular data. It's band 2, 3, 4, and 5. And in case if you're wondering what these bands represent, you can also go back to the Bhuvan portal here, and you can just check the metadata here. As you can see here, this sensor captures the data in four different bands. So the first three bands are in the visible near infrared range, and the last one is in the short wave infrared range. And all these four bands are capturing the data in the same spatial resolution, which is 24 meters, right? So the band 2, 3, 4 represents the visible near infrared range, and the band 5 represents the short wave infrared range, right? So I just have to select these bands. You can just drag and select them all together like this. Okay, you just have to press OK now. So it has been stored as a virtual stacked image here. After doing this, you just have to go to this drop down again, and then select the all option here, and now select the add button. So this virtually stacked image is added here, file, right? So just press the folder again, and then you can just save it wherever you want. So in this case, I'm going to save it in the same folder here. So let me just name it as stack 1, right? So stack 1.diff. Okay, and then you can also check this option here. So it will be ignoring the zeros. Okay, select OK now. It has run now. So you can just close this box here. So let me just open the file just to check it. So just right click on this map canvas here. Go to this open raster option, and then you can select this recent button here. Okay, so it will be showing you all the recent files which have been created. So this is the file which you want. So just click on OK here. So it will be adding it to the map canvas here. Okay, so it has been added. You can also zoom it to the layer by right clicking on it. Go to this fit layer to window option. So this image has been stacked, and you can also cross check it by going to this multispectral tab here. So you can just toggle with all the layers in this image. So as you can see here, it has 4 layers inside this, and since you already said the first 3 layers are in the visible near infrared range, and the fourth one is the shortwave range, right? So let me just toggle the layers a bit so that it will be creating a false color composite image. Okay, so let me give the red color gun as layer 3, green as 2, and blue as 1. So as you can see, this is the perfect false color composite in which the red color gun represents the NIR range, and these are vegetation areas, right? So you just have to do the same process again for the remaining 3 zip files, remaining 3 satellite data. So I have layer stacked the bands of the remaining 3 images, and I have created a false color composite for the same. So as you can see, these are the remaining 3 images here. So now we have to merge all these 4 raster data into a single raster data, because only then you'll be able to perform the subset analysis, right? So for that you have to merge them into a single raster. So the tool which we're going to use for that is a Mosaic tool. So for that you have to open the raster tab again, and then go to this Mosaic drop down. Okay, and then select this Mosaic Pro from 2D view. So this option will directly take into account the raster data that is available on the 2D viewer, right? So just click on this. It will be opening a new dialog box now. So as you can see, this is the dialog box here, and the data are automatically inherited here. So you don't need to tweak anything here. Just have to open this process button here. So you just have to press this run mosaic option. Okay. So it will be asking you for the output file's name. You can just give a name of your wish. I'm just going to give it in the same folder here. Mosaic.diff, right? So this will be combining these raster data into a single file, and this file will be named as Mosaic. It is running now. It's done now. So you can just close this box here, and you can also close this box. It will be asking whether you want to save this model. I'm going to just click no here, so because I won't be needing this model again. So we can now just check the result by just right clicking on the canvas here. Open the raster layer, go to the recent option, and then this is the file which we recently created. So it is mosaic.diff. Click OK, and then click OK. So as you can see, those 4 rasters have been merged into a single file. So let me just uncheck all these stacked layers first. Press the first one, and then press shift and press the last one. Right click on it, remove layers. So as you can see, this is the layers stacked on the mosaic the single image. So now we have to perform the subset analysis. So for that, first you have to input the steady areas boundary. Okay? So let me just add the steady areas boundary here. So the steady area is in the vector format, right? So you have to just right click on this here, open vector layer. Okay, you just have to go inside the folder. So in this case, I have saved it in the E drive. So this is my steady areas boundary. Okay, it has been added here. So the important thing to note here is that we will be able to do this subset function only if and only if this vector format is in the dot AOI extension. That is, we can subset the image only using the area of interest format. Since this vector file is in the shapefile format, we have to convert this into a .aoa format for us to clip this satellite data using the steady area boundary. So for that, what you have to do is that go to the home tab here and then select this select option here, the steady area. It will be turning into yellow. So now you have to go to the home tab again and then select this paste from selected object, right? So what it will be doing here is that it will be creating a new AOI layer. In that AOI layer, you'll be having this shapefile content. Understood? So just select this icon. So it will be creating a new AOI layer here. And as you can see, this layer contains the information of this shapefile. Let me just uncheck this. So you can see the boundary here. It has been saved in the .aoa extension. If you want to save this layer permanently, you can just right click on it and then go to this save layer as option. So let me just save it as Chennai itself inside the list folder. Okay, so it has been saved. So now we can perform the subset analysis. So for that, just go to the raster tab again, subset and chip option, create subset image, right? So it will be opening a new box here. So you have to give the input file as a mosaic here. Okay, let me save it in the folder, in the same folder again, 3 avoi.py. Right? Okay. Apart from this, you just have to enable this ignore zero output stats. So you can leave the rest as default. So now you have to specify the AOI file. So you have to specify the file which we just now created, right? Just click on this AOI button here, and then select this AOI file option. Open this folder button. I can just go to the folder in which I have saved it. So it is Chennai. Select OK. OK. So everything is fine. Just click OK now. Done. Close this box. So let me open the raster layer now, which we have just now created. Recent AOI.diff. Okay. So it has been created, and as you can see here, so let me just remove all the remaining layers now. So let me just tout the layers now, so that you'll be able to see the false color composite. So the red color gun will be layer 3, and green will be 2, and blue will be 1. So with this, we have learned how to download the data from the net, and how to layer stack it, and how to subset the image based on the AOI boundary. Please do subscribe my channel for many more interesting contents like these, as we are going to see many more topics like the pre-processing of the satellite images, performing the image classification techniques, and also the change detection, etc. So please do subscribe, and please keep tabs on my channel for many more contents like these. Thank you so much for watching.